In this lesson, we're going to learn how to solve quadratic equations by common factoring. We're going to talk about what a quadratic relation is or quadratic equation is later on in the video, but so far from grade 9 we haven't dealt with anything that looks like this, where we have a squared term and then, a squared x squared term and then another x term. So can we solve this? If we try to use the techniques that we've used so far, or know so far, we'd probably be tempted to move that 6 over. So we'd have x squared minus 5x is equal to negative 6. But how do you get x by itself? Because the problem is I've got two x's. Which x do I get by itself? Can I combine these? Well, they're definitely not like terms, because this has an exponent of 2 and this has an exponent of 1. So what if you have more than one term of different, or more than one variable of different exponents? Well, we can't solve it using traditional methods. But what if I rewrote it like this? So this is actually the same thing as this one, and we can just check that really fast by expanding it. So multiplying the x in and then the negative 2 in. So we would have x squared minus 3x minus 2x plus 6. And if we simplify that, and we've got an equal 0 on this side, if we simplify that, we have x squared minus 5x plus 6 is equal to 0. So that means that this is just another way of writing this. This is expanded form. And this is, but it's broken up into two binomials that are multiplied together. So could we solve it if it looks like this? Well, the right side's equal to 0. So could I guess a value right in there that would make the entire equation equal to 0? Well, what if I put in a 2 here? What would this term be? This term would become 0 because 2 minus 2 is 0. So I'd have 0. If I put in a 2 here as well, I'd have 0 in the first term. And we have 2 minus 3 is negative 1. But it doesn't matter what this ends up coming out to, because 0 times anything is equal to 0. So that means that 2 must be a solution. So one solution is 2. Can you spot another solution to this? Well, what if I put in here a 3? If I put in a 3, 3 minus 3 will make 0. If I put in another 3 here, 3 minus 2 will make 1. It doesn't matter what that number comes out to, because 1 times 0 will make 0. So that means that this is also a solution. X is equal to 3. So recapping, when the equation looks like this, expanded form, and we've got more than one variable with different exponents, we can't solve it using the methods that we've learned so far. It has to be written like this, where we've broken up this expanded equation into two things multiplying against each other, all equaling to 0, so that we could just guess and check our solutions. So if it's written like this, where we've got multiple things multiplying against each other to make 0, we can guess and check the solutions. That form that we were just talking about, where two or more things are multiplying against each other, is called factored form. So expanded form is when the expression is simplified as much as possible. There should be no brackets left. So I'm going to give a numerical example of 24. Factored form is when an expression is broken up into two or more expressions that multiply together to get the original expression. So in elementary school, you were asked to factor 24, and someone might have come up with this, 4 times 6. So 4 times 6 is equal to 24, and it's just broken up into two things that multiply together to make 24. So this is factored form. Someone else might have come up with this, 2 times 12 times 1. That also makes 24. It's broken up into three things that multiply against each other to make 24. So these are both factored forms of 24. Now when we start looking at expressions, we're going to learn how to figure out what the factor form of these expressions are. We know how to prove that x minus 1 times x plus 2 is equal to this. We can see here are the two factors. X minus 1 is the first factor. X plus 2 is the second factor. And when we multiply together, and we can prove it by expanding and distributing, it's going to equal this guy here. Here's another factored form right over here of this equation. 2x is the first factor, times x plus 2 is the second factor. It's going to give us this expanded expression. And remember, the whole point of factored form is that when it's factored, we can guess and check solutions. Here, it might be very difficult to understand what, or to guess what the solution is this if it equal to 0, but here it's much easier. In grade 9, we mostly dealt with linear equations, and now we're going to start to work with quadratic equations. So quadratic and linear equations can be differentiated based on their degree. So the degree of a polynomial is the highest exponent of its monomials with non-zero coefficients. So what that means in English is the degree is the highest exponent of the variables in a equation. So a quadratic equation has has a degree of 2, which means the highest exponent of the variables in that equation is 2. A linear equation has a degree of 1, which means the highest exponent on the variable will be 1. So let's see if we can figure out the degrees of these polynomials. So we can see that this polynomial has 2 variables. The exponent of y is 1, the exponent of x is 1, which means the highest exponent is 1, therefore the degree is 1. So that is the definition of a linear relation. Taking a look at the next one, we have again 2 variables, x and y. Y is a degree exponent 1, x has exponent 2 and 1. The highest exponent of all is 2. Therefore, this would be a quadratic equation. Keep on going. We have 2 more variables, y, it has an exponent of 1. Then we have this x, and both of them look like 1, so this must be linear, right? Well, no, this is factored form. We want expanded form. If I were to expand this guy, multiply these, wouldn't I get x squared? Dot, dot, dot. That would be the highest exponent once it's expanded. So we can only tell the degree once it's expanded. So this degree is also going to be 2, and it's another quadratic. How about the next guy? Can you figure it out? We can see an exponent of 3 on the x, therefore the degree is 3. How about this next guy? We have a variable of 1 here equals 0. What is this if we were to graph it? If you're not sure, pop it into Desmos. And you're going to see that this is just the line where y is equal to 0. So this is a horizontal line. The highest exponent is 1 on the y, so it is linear and degree 1. And finally, we got this funny looking guy. We've only been dealing with examples where the exponent of y is 1, but here the exponent of y is 2, and the exponent of x is 2. So the highest exponent is 2. This is another quadratic equation, and when you graph it, it's actually going to become a circle. So now that we know what a quadratic is, and we know that in order to solve a lot of quadratics, they need to be in factored form, let's make sure we can actually guess and check the solution when it is in factored form. Let's take a look at this guy here. So a couple things to notice. One, is this actually a quadratic? Well, if you were to multiply the 2 times x, we get 2x, and then 2 times 3 is 6, so that's just 2x plus 6, which is actually linear. But if it's factored for us, we can solve any type of equation if it's factored. The other thing that we got to notice is that on the left side is it's equal to 0. So it doesn't matter which side that 0 is on, but as long as the equation is equal to 0, then we can guess and check. It's going to be a lot harder if this was like 5. Something plus 3 times 2 equals 5 is a lot harder than just figuring out something plus 3 times 2 is equal to 0. So can we guess this value right here? So what plus 3 is going to make 0 to make this entire thing 0? Because remember, if I do 2 times 0, it's going to equal 0. So if I put in a negative 3 in for x, then we have a plus 3, and then it's multiplying by 2. Is that going to be 0? Well, we know that negative 3 plus 3 is equal to 0, so it's going to be a 0 times 2 is equal to 0. So our equation is equal to each other, and we found a solution. So we know that the solution to this equation is x is equal to negative 3. Let's try it for the next guy. So now we've got 2 x's, and therefore we could have 2 solutions. And when I multiply this, 2x times x, is going to be x squared. We know this is going to be a quadratic then. Notice it's also factored. We've got two different terms that are multiplying against each other. So we've got 2x as the first term and x minus 1 is the other. And one side is equal to 0, so we can guess and check. So can we just start figuring this out? What could x be here in order to make everything equal to 0? And what could x be here? Well, maybe the second one's more obvious too. If we put in a 1 here, 1 minus 1 is going to equal 0. And therefore the entire thing is going to be 0 because 0 times anything is 0. So now we have one solution. One solution is that x is equal to 1. How about this other guy here? What could I plop in right there to make the whole thing equal to 0? Well, what if I put in 0? So imagine this, 2, and then times 0, and then times 0 minus 1. 0 minus 1 is not 0, but because we have the 0 here, the entire thing equals 0. Therefore, we have a second solution, which is that x is equal to 0. So we can either write it as two separate statements, or we can write that x is equal to 0 or could be equal to 1. So here there were two solutions. How about this next guy here? So try figuring this one out on your own and then come back to the video. Did you figure out both values for x, or were you able to figure out only one of them? Well, let's take a look right now. So we've got two different x's. We know this would be a quadratic if we expanded it. We also know the left side is equal to 0, so we just want this factor to be equal to 0 and this factor to be equal to 0 in order to satisfy the equation. So for this guy right here, maybe this one's obvious to you. If we plug in a 0 here, then we would have 3 times 0 times 2 times 0 minus 1. And because we've got this times 0 right here, the entire thing would be equal to 0, and we have a solution. So we know that one solution, we'll put it over here, is x is equal to 0. How about this other guy here? So how about this one? What would I have to put in here? Well, I see a minus 1 here, so if I put in a 1 there, then I have 2 times 1 is 2, minus 1 is equal to 1, not 0. So what could I put in here to make this whole thing equal to 0? Well, a lot of the time we can just figure it out by looking, but if you have trouble finding it by looking, we know that we want this guy to be equal to 0. So just set it equal. So say, what if 2x minus 1 was equal to 0? What would x have to be? And quickly solve. So bring that minus 1 over, and we've got 2x is equal to 1. And then we're going to divide by 2 and divide by 2, and x is equal to 1 over 2. So put that 1 over 2 back in here. Well, what's 2 times 1 over 2? That's just 1. And then we have 1 minus 1, that's 0, and the entire thing is equal to 0. So we have two solutions again. X is equal to 0, and x is equal to 1/2. Let's take a look at this example. This equation's factored, but we have a 2 here. So can we actually solve for this? Something times 3 times that something minus 1 has to be equal to 2. Can we even figure that out? Maybe, but it would take a really long time. And so here we can't really solve it. So this is not solvable in a method that we know. What we'd have to do is basically start all over again, refactor. So we'd expand this x into this binomial, move the 2 over, and refactor. But we don't know how to factor yet, and that's where we're going to get to right now. There are many techniques to convert an equation from expanded form to factored form. We're going to learn the following in this course. We're going to learn common factoring, that's one technique. Another is decomposition and sum and product. And a last is difference of squares. We're going to focus on common factoring right now. So in common factoring, we're going to look for factors that each term in the expression has in common. So we're going to look for a factor that evenly divides, or a term that evenly divides into the expression that we're given. And that's the definition of a factor. So for example, if I was looking for factors of 24, I'd be looking for numbers that evenly go into 24. So is 5 a factor? Well, 24 divided by 5 is not an even whole number. or I should say an even integer. However, if I take 24 and divide it by 4, I get the integer of 6. Therefore, 4 is a factor, and not only is 4 a factor, 6 is a factor as well. So we're going to do the same thing that we did with 24, but we're going to do it with an expression. We're going to look for something that evenly divides into the expression and all terms of the expression. So just a important reminder is when you expand the expression after we factor it, it should give us what we started with. So we always have a check. At the end, we can always check. Expand it, see if we get back what we started with. So let's try a few solving examples. Before today, we'd never be able to solve this. How can we collect these terms and get 1x together and get it by itself? We can't using the methods we used in grade 9. So we have to factor this thing. So we're going to factor it and then we're going to solve it. Note that one side's equal to 0, and that's really important for us to be able to solve. So if 0 is equal, and now let's try to common factor this thing. So is there any term that 3x squared and 6x has in common? Another way to think of this is there a term that will evenly divide into this term and this term? We'll take a look at the numbers first. Is there any number that divides into 3 and 6? Well, yes, 3. So I'm going to start by taking out a common factor of 3. Common factor. So now we got to just figure out what's left over here if I were to divide that common factor into each of these terms. So one way to do that is to actually physically divide 3x into here. What would be left over if I took out 3x? Well, taking a look at the first guy, 3 divided by 3 is 1. We know x squared divided by x is just 1. If you can't remember your exponent rules, remember when we're dividing variables with the same variables with all we have to do is subtract the exponent. So 2 minus 1 is 1. So x squared divided by x would just be x. So we would be left with 1x, or just x. And then if we divide this guy, we know that negative 6 divided by 3 is negative 2. So we have negative 2. And then we have x divided by x is 1. So we just have negative 2. And this is what we're left with factored. Let's triple check and multiply this out in our head. What's 3x times x? That's x squared. And what's 3x times negative 2? That's going to be negative 6x. So we know that we factored this correctly. And now that we factored it correctly, we can solve. And we practiced solving already, so try the solving on your own and come back to the video. So if you're back in the video, you should have solved this on your own now. We know that we can put in 0 for x here to make the entire expression equal to 0. So that's one of our solutions. And we can put a 2 in here. So 2 minus 2 is equal to 0, and the entire thing will become 0. So our two solutions are x is equal to 0 and 2. And something that I don't think I've made clear so far is that when we're looking for factors, we're looking for numbers and letters that go into our terms. We're looking for the greatest common factor. So we're looking for the biggest number and biggest variable and exponent that can go in each of the terms. So let's try B. So again, we can't solve this just by moving things around to collect the a's because we've got an a squared and an a. So let's try common factoring. So we're going to look for the greatest common factor in both of these. So one side is equal to 0, which is essential for us to be able to factor this. Taking a look at both of the terms, we're going to look for a coefficient that goes into both 25 and 20, and we're looking for the biggest one, and that would be 5. So our first part of our greatest common factor is 5, and then take a look at the letter. We've got an a squared here and an a. They definitely have a in common. There's 2 a's here, 1 a here, so the most we can take out is 1a. So now for the fun part, what would be left over here? Well, I showed you one way of figuring out what would be left over here, and that would be by dividing each of the terms by 5a and seeing what's left over. Another way to think about it is like a sort of a fill in the blank. What could I put right here so that when I expand it, I get 25a squared? Well, what needs to multiply by 5 to get 25? That would be 5. So my first guy would be 5. What about a? A times what is going to make a squared? Well, a times a. So I'd have 5a. And then do the same. What would I have to put here so that 5a times something is negative 20a? Well, to make that negative 20, we need a negative 4. And if I just check, 5a times negative 4 would make negative 20a, and I've got it. So now it's factored, and I can check it by expanding it. So now we've looked at two different ways to common factor. Once we have our greatest common factor, you can divide that greatest common factor into each of the terms to figure out what would be left over, or you can do sort of a fill in the blank. What would I have to put here so that when I expanded it, I get each of these terms? Now that we've done that, we can solve, and go ahead and solve on your own. If you're back at this video, you've solved on your own and you should have gotten these two answers, 0 and 4 over 5. So this guy's easy because 5 times 0 will make 0 times anything else will still be 0. So that has to be one of our solutions. And this guy here, remember, if you can't figure it out in your head, just pull it out and work on it separately. So if we have to set 5a minus 4, if we want it to equal to 0, we'll just set it equal to 0 and solve. So we have 5a is equal to 4, and therefore a is equal to 4 over 5 when we divide that guy. One final example. Let's take a look at this guy. We want to solve. Well, we've got b squared, we've got b. We know we can't collect those b's together and isolate for them, so we've got to factor. So a problem is one side is not equal to 0. We've got to make that happen first. And also we've got these like terms that we really should add together before we try to do anything. So it doesn't make any sense to bring the 17b over here, because we need one side equal to 0 so that we can guess and check. So it makes a lot more sense to send this 2b over so that we have 0 is equal to negative 3b squared. And then we'll have 17 minus 2b is going to be positive 15b. And now we can common factor. So I highly recommend pausing the video, try it on your own, come back and check to make sure you got the right answer. If you're back at the video, you factored this and you're checking your answer. Our greatest common factor is negative 3b. Notice how I didn't take out a 3, I took out a negative. It's really important that whatever's in our binomial has a leading coefficient that's positive. It's just going to make our life easier moving forward. So our monomial can be negative, but whatever's inside this binomial, the first term should be positive. So I took out a negative 3b, and I was left with b minus 5, and now we can solve this thing. If b is equal to 0, negative 3 times 0 will make 0. The whole thing will go to 0, so that's one solution. And if I put in a 5 here, 5 minus 5 will make 0. The entire thing will also equal to 0, and that's our final solution.